Hi all. So Willem kind of voluntold me to talk about OpenWebRx. I've been deploying it various places on the RMHAM network, and it's been working out for people. But
I want to say that we need to switch displays.
Yeah, push button number 2 on the black badge there.
Push button number 2. And the Windows box is trying to do closed captioning, so we'll see how that goes. That's new and shiny. Anyway, we'll just ignore that for now. So before we start talking about OpenWebRx, I guess let's talk about SDR. SDRs are typically wideband receivers, so they don't necessarily have to be attached to a computer. The computer does most everything, and the SDR does just a little bit of data capture. But, you know, math is hard, so we're not going to talk about the details. If you're interested in that, these folks made me give another talk a couple months ago. I'm sure you can find that on the web. Apparently it's on the RMHAM YouTube page, so that's good. A quick legal mention though, SDRs are pretty flexible devices. Most of them don't do any sort of blocking or filtering, and there are some IP patent law things that'll come up in this talk. So I'm not a lawyer, RMHAM's not making legal advice. Yeah. So anyway, you bought an SDR. These are pretty cheap. You can get one for 20 or 30 bucks on Amazon these days. Now what? You need some software. There are options for all the usual suspects. What you choose may depend on whether you want to transmit or not. We're not going to talk about transmit too much today. But let's talk about the hardware options. So kind of easy mode, money is no object. ICOM will sell you a shiny box that looks like a traditional radio, but is actually doing SDR. And you can get the SDR data off it and process it with another computer, or you can use the built-in computer. Has real filters in it, probably a little bit narrower band than some of the other things we're going to talk about, but works really well and just does radio. Slightly harder, you can get something from Flex that may or may not look like a real radio, but has all the radio bits in it, has filters, has a power amp, transmits, all that good stuff. But provide your own computer, provide your own software. Flex still has some software they'll give you, which makes it a bit easier. And then what we're going to talk about for the rest of the hour, kind of hard mode. Get on the web, buy an RTL SDR, buy a hack RF, buy a Blade RF, more or less in order of increasing money here. These guys are just pretty much A to D converters and fast interfaces to your computer. The RTL SDR is by far the cheapest. That's the $20 or $30 option. Those are actually TV tuners for European TV that somebody figured out that if you rewrite some things in the driver, you can get it to capture pretty much whatever you want, DC up to a gigahertz or 2. So those work really well. Hack RF was, I think, born in Denver and is a little bit more designed for hobbyists. It does have a transmitter in it, but I think it's like 10 milliwatts, so kind of just barely. The Blade RF stuff, about $1,000, but you can get multiple tuners, transmitter. SDR Play, I think John's going to talk about in a little while. Those are nice because they have some filters for the ham bands. And a good preamp. Kraken SDR is another one that's people pointed me at after my last talk. That has 4, now 5, I guess, the new version, yeah. Coherent receivers, so you can do direction finding and things like that with clever software. So it really depends what you want to do. Other things you need, obviously, some sort of antenna system. All the usual rules apply for that. But external filters can be a good idea. Again, the front end on these things might be a gigahertz wide, so they're pretty susceptible to noise. Good quality cables. A lot of these use USB or Ethernet. USB cables can be noisy. USB buses can be noisy. Cheap power bricks can be noisy. So, you know, all the usual radio things still apply. On the computer side, faster computers are better, but you can do this with fairly low-end computers. So most of this talk is Raspberry Pi. Willem tells me that hams like Raspberry Pis. Don't know. They are cheap. They're also basically unobtainable right now. So you better already have one. So where to start? There's this neat package called OpenWebRx. It gives you a web interface to your SDR and all of the usual sort of radio-ish controls, if you know, the things you'd expect from a traditional radio. Linux is involved, but we're going to present the web interface. So a lot of this talk is walking you through getting this set up, and you don't really need to know much Linux. It comes with decoders for various modes. So if you are the type of ham that has a D-Star radio, a Fusion radio, a DMR radio, a P25 radio, and no space at home, this will do it all, almost all, which is really nice. The downside, of course, is it's receive only. Not sure if there's anything on the roadmap to change that. The transmit side of SDR really isn't as mature software-wise. There are some options, but not really very good ones. So this is kind of what it looks like. You have some controls on the bottom right and a waterfall. So I think we talk about what the waterfall is in a bit. You've got some mode selection, so FM, sideband, and whatever digital thing is fun these days. Bottom right there. Device selection. So maybe you want to try all the SDRs and you bought 2 or 3 of them. It doesn't care. As long as you can get them plugged into your computer and you have a fast enough computer, you can switch between them. If you have multiple people viewing this web interface at the same time and you have 2 SDRs, they can be used at the same time. The main constraint is that if you have multiple people viewing, they all have to be on the same band for a given device. So if you have 2 devices, you can have 2 people on 2 different frequencies, no problem. Or, yeah, as long as it's within the bandwidth of the receiver. But if you have 1 receiver and 2 people and they want to be on opposite sides of the spectrum, well, oh well. They'll fight and whoever clicks last wins. So we've talked a little bit about trying to make some of these available for general use at some of the radio sites RMHAM maintains, and that's the big challenge. So you got a dial frequency at the top. Now it's an SDR, right? So you can capture a megahertz, 2 megahertz, 5 megahertz. Really depends, you know, only limited by what your SDR can do and what your computer can process. For what it's worth, the Pis are good for maybe a megahertz or 2. So once you have that data, you can retune it to whatever you want within that sort of band slice. And here you do that just by clicking on the waterfall. Maybe you see a signal you want to listen to and click on it. Depending on your SDR, there may be some artifacts right around whatever the 0 frequency is, whatever your kind of dial tune frequency is. So it's actually a good idea to tell OpenWebRx to listen to not exactly the frequency you want, but something a little bit offset, and then click the one you want. So yeah, waterfall. We have on the y-axis time and on the x-axis frequency. This is doing an FFT. So we're taking the signal and converting it to frequency domain, and the colors represent energy. So this is really a very convenient way to find signals. You can just visually look at this, and probably doesn't show up real well on the TV, but you can see that you have something going on here and it really sticks out. So maybe you click that and see what it sounds like. Ah, yes. This particular SDR lives at a radio site south of here, and that is a DMR transmitter desensing it.
Welcome to my world.
So yeah, I mentioned other decoders. Obviously, the 2 meter band here is a little bit quieter. We can listen to packet, and it will decode here. So you'd click digital, choose packet, and get some decoding there. And this goes for all of the usual suspects, the WSJT or whatever it is, that whole family of protocols. FT8, I think, is pretty popular now. Those are all in here, Whisper's in here. You name it, there's a decoder for it. And if there's not a decoder for it, there's a nice plug-in API. So go ahead and write one for the rest of us. So how do we get one of these OpenWebRx instances set up? Well, the easiest way is to cheat and find one on the internet. And this is actually pretty convenient if you're debugging other radios, because you may be able to hear yourself. But that's no fun. So let's go shopping. You're going to need a Pi or a computer, but we're going to go with Pi for now. I would strongly recommend a Pi 4. We have this running on a Pi 3 in a few places, and it's not beefy enough. It does work, but it limits how much spectrum you can listen to and what decoders you can run. Some sort of SDR. The RTL SDRs actually work a lot better than you'd expect. It's a company called Noalec, and you can buy their stuff on Amazon that has slightly beefed up receivers. Yeah, Willem has one. Everybody uses the same one. They work pretty well. You may want a little USB extension cable because by the time you stuff that in your Pi and anything else, you're going to physically block the rest of the USB ports. Some sort of antenna. Disc cones work really well because they're very wide band, but it doesn't really matter. Pick something that will receive what you want to receive. Some sort of micro SD card. The sort of published image for OpenWebRx is only about 2 gigabytes. So whatever you can find cheap should work. Better brands are going to be more reliable though. And some sort of micro SD reader. If you want to do this on kind of the easy way, you might want an HDMI cable for your Pi, but you don't really need one. We're going to show the process without. So again, the easy way, we can download a pre-built image from the OpenWebRx website. I personally generally prefer to build things from source. And if I say I'm going to show you how to do it, but I'm not, I'm lying. But if you ask me, I do have some scripts for that because we've set it up that way a bunch of times. You also need a way to get the image onto your SD card. So I would suggest just using the Raspberry Pi imager.
Real men use DD.
Yes, and we'll get to why using DD is inconvenient in a minute. So anyway, download the image. What is it? Sure. Etcher will work fine. We'll get to why that's problematic in a minute too, I think. Anyway, so we can click through, download your image, unzip it, open it. So this is obviously one that the tool doesn't know about. So we pick use custom, pick file name, pick what we want to write it to. Be very careful and write to only the thing you want to write to. I have had a couple of students at work actually erase servers this way. You know one of them. So there's the settings panel, and it turns out that the state of California has decided to save us from ourselves, as well as the UK government, and they're not allowing you to have default accounts anymore. So the Raspberry Pi folks the other day announced that there's no longer going to be a default account in Raspberry Pi images. That's why some of these other tools are problematic, because this will write some metadata onto the boot volume of the SD card to configure your image for you and let you log in easily. There are other ways of handling it, of course, but
can you still add the default Pi user?
Yes.
Okay.
And then you should not put it on the internet because that's a well-known thing to attack. But yes, if you were to watch this closely, you'll find that I add the default Pi user and the default Pi password because I'm a bad person and on a private network. But this is actually pretty convenient because we can set the host name, we can enable SSH, we can set the default username. We can configure it, tell it what time zone and all that good stuff. So you want to click through here. You can set a Wi-Fi network if you want to use Wi-Fi. If you don't want to use Wi-Fi, just plug Ethernet in and it should work. So this is nice though, because I don't have to go find a monitor or find the little HDMI adapter. Just plug it in, turn it on, good to go.
So I've not used Pi Imager before. Does it run on pretty much any OS?
The three usual suspects, Windows, Mac, Linux.
Okay.
You could probably trick it into running on BSD if you really wanted to. Hit the right button, wait a second, insert the SD card into your Pi, turn it on, wait a bit, hope for the best. If you That would involve plugging a screen in. That's too much work. We can't do that. But yes, if you get something on the screen, that's a good sign for sure. So if you're lucky, you configured your Wi-Fi stuff in the imaging tool correctly, and you have a network that's set up in a cooperative way, you can probably point a web browser at http:// whatever you set the host name to. And maybe that's all you need to do. If not, you need to figure out what IP address your Pi got assigned. So look in your router. Hopefully there's something there that will tell you. If all else fails, you can break down and plug an HDMI cable into the Pi, log in, run ifconfig, and it will tell you. You can use an IP address instead of a name. But this actually worked for me, and I have a pretty simple router. So I think there's a good chance. Anyway, you should see something like this. This one's actually running in my living room, hence the white noise and no signals. Of course, if you want to change any settings at all, and this comes pre-set up for an RTL SDR or something called an AirSpy, which is yet another brand of SDR. And it comes set up with profiles for a small chunk of the 70 centimeter band and a small chunk of the 2 meter band. If you want anything else, you have to configure it. And unfortunately, they don't have a default login for this either. So you'll need an SSH client. If you have a recent Windows or anything Unix-based, you can just open up a terminal, and SSH to whatever you opened in your browser. Other Windows people, Windows 7 or older, might want to download a copy of PuTTY, or even those of us on newer Windows. And again, put in the IP address you have, and make sure SSH is clicked, hit open. Log in with whatever you gave it when you set up the SD card. And we're going to run sudo open WebRx admin add user admin and set a password. If you're going to put this on the internet, the password should be something reasonable. If you're not, I don't know, admin works, whatever.
What is sudo? What is sudo?
What is sudo? So Unix boxes have this concept of a root user that has all the power, right? Is able to write to other users' data, able to do whatever, talk to hardware. The sudo is a way to run a command is that privileged user without actually having to become the privileged user. Now, for those of us who spend all day as Unix admins, what you do is you say sudo su minus and you become the root user with sudo anyway, and you're a bad person because as soon as you make any mistakes at all, you have the permission to crack the system. Yeah, I've never done that either. I don't know anyone that's ever done that, but I've heard it happens. So this is nice because it allows you to run a command that way, but one command, which we presume is a safe command. No promises, of course. Luckily, it's a Raspberry Pi and an SD card. If you screw it up, erase the SD card and start over. No big deal. Yeah, that's never happened either. That's not a feature I've ever used, never. So anyway, that looks like this, and you can see the stack trace that happens when you misspell something in the top of my window. That also has never happened. I did that for theatrical effect. So anyway, let's do some configuration. There's a settings box in the top right. Hopefully you've successfully added a user that you can, put in here. We're going to choose SDR devices and profiles. Now, if you don't have one of the default SDRs, you'd want to add it in here. It looks like this image comes with the drivers for the SDR play as well. Haven't actually tried that in the image, but the SDR plays definitely do work. If you're using one of the ones that comes pre-configured for, you can click through and delete the other two if you want to, or just ignore them. I'm just going to ignore them. But you're going to want to click the one you want to use, and you're probably going to want to click New Profile. Obviously, like the RTL SDR, like I said, you can receive just about DC to a gigahertz or so. It gets less sensitive around the edges. So we're going to want to add a new profile, and it's going to ask you for some things. the profile name. So that's what shows up in the web UI. Probably that's, you know, you're gonna want that to be descriptive, 2-meter repeaters or 20-meter band or whatever you want to put there, right? The center frequencies. So this is kind of the dial frequency of the SDR. The data the SDR collects is going to be on either side of this frequency. So if I collect a 2 megahertz chunk of spectrum and I set the center frequency for a megahertz, I'm going to get 0 to 1. And the sample rate. So this is the amount of spectrum that's collected. And again, this depends on the SDR hardware you have and the particular computer you have. The RTL SDRs, general consensus is they're good for about 2.4 megasamples per second. They'll do a little more, but you might start dropping packets on the USB bus. So you might see holes in your data. Feel free to experiment with this and get the biggest number that still works. I've found 2.5 to work okay, maybe more than that, not so much. It depends on the USB bus and your computer and phase of the moon, whatever. The initial frequency, this is where that kind of little caret, it ends up when you first open up the interface. So obviously it has to be in the band that you figured. Other than that, you can set it whatever you want. And the initial modulation, again, this is a default. You can change it, but FM, one of the sidebands, I suppose you could choose one of the digital modes if you wanted to do that. So this is what it looks like. This is, of course, blurry on the TV, sorry. But how you might configure a chunk of the 20-meter band. Of course, HF is nice because all the bands are really small, so you can get the whole band in one sort of spectrum chunk. As you get up into the higher bands, 70 centimeters, you have too much spectrum to capture in one chunk, so you might have to do 2 profiles. Other things you can do, if you're going to put this on the web, you probably want to come in here in general settings and tell it that it's not in Hungary or whatever the default is. What kind of antenna you have, where you are. If you were to have scrolled down in this window, you can set up things like what the colors should be on the waterfall, how many buckets you want to do in the waterfall. So you can update the waterfall faster and you can have it be higher resolution. But if you do so, more CPU time. So Willem's actual ask to me was, can we decode DMR with this? The answer is yes. This is what it looks like doing D-Star. The DMR decoder is a little bit more finicky, so I couldn't get it to decode my radio from 5 feet away. The D-Star one will do it, but they both work. The problem with this, of course, is legal. So most of the commercial digital protocols use a codec called AMBE, which is still patented in the US, at least most of the versions of it. That's DMR, D-Star, Yesu's thing, Kenwood's thing, B25. There is a free codec available, free DV. Get on the soapbox a little bit here. Use the open source codec. Works pretty well. The downside, of course, is that you can't just buy a radio that has that codec in it, a chip, at least not easily. There's an effort in that direction. So what is AMBE? Well, if you want to take about 8 kilohertz of audio and shove it into a kilobit a second, you need to compress it to death. And AMBE is a proprietary way to do this. It's been around for quite a while. It's used in commercial radio. My sat phone has the same chip. It's pretty good market penetration. There are a few different variants. Most of the, as a ham, if you go out and buy one of these chips, that chip will do all of them. So how does it work? Well, you buy a chip, it takes raw audio, you give it that over a high-speed serial port, and it gives you back some symbols that you can transmit over the air. Or vice versa, obviously, if you have compressed audio, the chip will give you listenable audio back. Some of them can do multiple streams if you want to do transcoding. I don't know if any of you listen to the Fun Machine. Jeff has been working on this neat transcoding thing where you put in stuff from one radio and get out stuff from a different protocol, so everybody can listen with whatever radio they have. You need either a bunch of these chips or one of the fancy ones for that. But for what we want to do here, it really doesn't matter. If you go buy one of these things, they're just a little USB dongle. It's got a USB to serial chip on it and the AMBE codec. They're about $100. A couple different brands. I don't know, Willem, John, if you guys have a brand you like.
Northwest Digital, but they're the original, I guess. Yeah.
Okay, yeah, that's this.
On a little board with Ethernet and other interfaces too from, who's the guy who does the MMDVM modem?
Facing his no, Zimmerman.
Yes, right. Anyway, he does sell a AMBE board. It's a server essentially with an Ethernet interface and some other interfaces. And I ended up buying one of those from HRO, but that was the only one I could find. I could not find any of these dongles, and that was probably about 2 months ago, I guess. So good luck. The chips are hard to find.
Everybody's having chips.
Buying anything is impossible these days. Yes.
Real DVSI chips that are endorsed and not just a knockoff.
Yes, and
So
if
you're going to get pretty good audio quality out of this because you're paying the money.
And from what I understand, the knockoffs tend not to work very well with the software stack.
Yeah.
I don't have one. I haven't tried it. I have one of the Northwest Digitals that I bought years and years ago. And this will come up in a second, but there are different versions, different hardware revisions of some of these, and they behave slightly differently depending on when you bought it. So
Okay.
it's
Well, that was going to be my point of this $100 some price tag, probably 2/3 of this is going for the chip to the patent holders, but you're going to get much better quality. In this case, you get what you pay for.
Sure. Yeah. Yeah. I mean, the USB to serial adapter, that's the other thing on that dongle, is probably $1 of chip and then a little piece of plastic. As mentioned, though, that there's a server version of this. Unfortunately, there are 3 competing protocols for talking to these chips over Ethernet. OpenWebRx uses something called codec server that was written by I think the same guy that wrote or is currently maintaining OpenWebRx. OpenWebRx actually started out a number of years back as somebody's PhD project. The guy that wrote it kind of gave up on it after a few years, graduated, wrote the paper, done. But the community has taken it over, which is always nice to see. Anyway, this codec server thing, if you're building the stack from source, you can go get it from GitHub, but it comes pre-installed on your Raspberry Pi image. Unfortunately, not configured. So we have to SSH back in, and we're going to open up Etsy codec server, codecserver.conf in your editor of choice, and pretty much uncomment everything that looks like a configuration line. The defaults are mostly fine. There are a couple comments that explain what each line does. Don't uncomment those. Those are comments. But the rest of the config, pretty much you can turn on, save, and exit. So it should look like this if you do it right. You notice on the bottom here, I have specified, well, I have commented out a couple different baud rates. This is because it depends on what dongle you have. The Northwest Digitals started at the 230K baud rate, and if you have one from the last year or so, it's now twice that. I suppose that allows you to shove more audio through it faster. From looking at mine, I don't see a revision number or anything on it. So this was a little bit fun to figure out. These chips are kind of finicky. I guess set a baud rate and guess these 3 numbers. Pick one, try it. If it doesn't work, unplug and replug the dongle and then try another one. If you don't do that, the dongle can, you send garbage to the serial port, the chip gets in a funny state and it won't come up. So you can try all 3 baud rates and it won't work. So be methodical about this. Took me an hour to figure this out. Should not have. Yeah. So anyway, the 230K are the Northwest Digitals from more than about a year or two ago. The 400 is the newer ones, and this third number is some of the other brands.
So what kind of rate does that give you? I mean, we're talking about 8K audio. So that is a bit rate?
It's a baud rate, it's a symbol rate, but it's the symbol rate of the serial port between the Raspberry Pi and the AMBE chip. So as long as it is faster than you're feeding audio in, it really makes no difference.
Right. So, I mean, there's really the only gain that you would have running it at run 5 some.
2, at least. I think, I can't remember. There are limitations in the AMBE chip as well. But yeah, that's the basic idea. The 3. Yeah. This is defined by physical jumpers on the dongle. So for the purposes here where you only want to listen to one stream at a time, probably. Of course, if you have multiple clients trying to listen to multiple streams, maybe you want a fancier AMBE chip. But if you're just have one of these in your home and you want to listen to the radio, then it doesn't really make much difference. The important thing is you have to have this number be whatever the hardware is expecting. So to set this up, it's a regular systemd service, as is common with modern Linux installs. So make sure your AMBE dongle is plugged in and configured correctly. System control restart codec server. Check the status, and you should see something like the bottom of the slide. If it complains about not being able to reset, and it doesn't say something about creating some number of channels, it didn't work. Try a different baud rate, or unplug it, replug it, restart it. Like I said, they're a little finicky. Once you have it behaving, you can just restart OpenWebRx or restart the whole Pi. It'll come back up and you'll have more options in the little protocol box in the bottom right. But I thought we were talking about software-defined radio. What's up with all this hardware? Well, again, lawyers. If you were in a jurisdiction that didn't care about such things, Codec Server has a plugin interface, and there are at least 2 different software implementations of AMBE. Doug mentions audio quality. I personally think AMBE sounds terrible regardless, but yeah, the hardware may do a little better on audio quality, especially on an underpowered computer. But this is a thing you could try if you were in a country that didn't care about patent law, or you weren't giving a presentation for an organization you don't want to get sued. It's not very hard. You do have to compile it. It's not included in the image, but it's not very hard to install.
How compared to something that can run on a Pi?
Yeah, it can run on a Pi. It's not a very sophisticated algorithm. It's almost a lookup table. And we mentioned this before, but can you play with this for free? Well, yes. It used to be there was a guy that was running an aggregator, and all these OpenWebRx instances would check in with this aggregator, and you could have a whole list. You could sort them by signal to noise ratio or what kind of antenna they had, or pretty much whatever. Unfortunately, that guy gave up and got frustrated with the community about a year ago, and it doesn't exist anymore. However, the Kiwi SDR folks, and the Kiwi SDR is yet another piece of hardware. It's an HF radio, 0 to 30 megahertz. It's based on OpenWebRx, but is not actually OpenWebRx. It has a different set of decoders. You don't get DMR, but you do get slow scan TV and things like that, HFE things. You can go to this website and it will sort by signal to noise ratio. There are other options you can choose and go through, pick the SDR of your choice. Maybe you're trying to debug an HF radio and you want to find one a state over, the other side of the country, the other side of the planet, whatever. And you can play around with this interface without having to buy any hardware, which is pretty nice. Anyway, yeah, Willem gave me an hour and I've used almost 40 minutes. So we have plenty of time for a little bit of a demo if people are interested, or if there are questions.
Tell me how it works.
Okay. So I actually have two of these. You can see my terrible noise floor at home. But I guess it kind of depends what you want, right? If you want to just listen to your local repeater, type the frequency in here, hit FM or wide FM, and that's all there is to it. Or maybe I don't know, I'm new to the area, I don't know what's around. So I just picked the repeater section of the 70 centimeter band, which this is not, but that's fine. And I see some signals over here, so I can just click one of these signals. Hopefully that shows up on the screen. Yeah, it does.
So what we're seeing is your WebRx running at home?
Yes. Through the magics of VPNs and the cell network, you can see what the little antenna clipped to my curtain rod at home hears. Not a whole lot, generally. But this is nice because you can visually pick out what's going on very easily. And you can see there's a kind of a weaker signal here. So especially for things like HF, it's really nice to be able to find the signals. You're not just spinning a knob all day.
I have a question from the chat.
From the internet.
How about listening remotely, like via the internet? Does this app support that?
Yes, that's actually exactly what we're doing now. This is running in my living room up in Coal Creek. And you can maybe, I have no idea where the audio from this computer is going. It's feeding into the HDMI. It's probably not worth it. But if you want to take my word for it, yes, there's audio coming out of this computer and it's hearing RF from somewhere else. It's going to take, yeah, so. Yeah, that's probably the Thornton DMR. Anyway, I can't believe I hear El Dorado. That's cool. So this is actually exactly what's cool about these things, though. I didn't know I could hear El Dorado from home. I probably shouldn't be able to. Most things to the north I can't hear, but there it is. All the more reason it shouldn't work. But this is a fantastic way to figure out what you can hear. Yeah, so if you look down here, that's neg 35 dBs in whatever universe the RTL SDR is returning. So
You said negative 35 dB?
that's what it says.
But I guess that's negative 30. That's negative 35 dB to something, not dBm necessarily.
It's supposed to be dBm, but it's a $20 device. So it's they're actually pretty accurate. So Jeff and I was driving up north a while ago and we were trying to test out West Creek. And it turns out that West Creek has blown one of the two transistors in the PA on the GE Master 3 that runs the Fun Machine.
Okay.
And we can tell this because on the same combiner, there is a DMR machine at 50 watts and a GE at 50 watts. So you can compare them and the relative powers are pretty close.
Okay.
But the absolute numbers make no sense.
I was going to say, because if that really is El Dorado, there's no way that could get minus 35 dBm into your living room on a curtain rod. So it's obviously a different number, but it's a very useful number, but it's probably not calibrated in dBm.
Right. If you wanted to calibrate it, there's software tooling to calibrate it, but you'd have to have something to calibrate it against, which as a ham, I don't. If you were Doug and you had a bunch of expensive test equipment, you could get this pretty dead on.
That's a pretty simplistic or easy thing for me to do, just like it's pretty easy for you to look at this software code that we're running and you go, what takes me 5 weeks, you come up with in 5 minutes. So yeah, we each have our skills, but you could look at Thornton, you could look at El Dorado, and that's very useful because now you have a tool. Like you said, I'm looking at things on West Creek. You've got a very powerful tool here for how many bucks?
30?
30 bucks.
Well, okay, you need the computer too. So like 75 all in,
Yeah.
maybe, with the cables and everything.
Pretty damn cool.
But it's cheap. And there's other software you can use if you want this to look like a spectrum analyzer instead of look like a radio. No problem, right? It's all software. But yeah, this is actually how I ended up here today and got stuck here. Jeff called me. We were going to go to West Creek. I was in mostly to see the site, and you know, I've never been to that part of the state, so what the heck, right? And he's like, well, we were going to bring in an SDR to let us know if anything's broken or not. Okay, fine. But the guy that was going to bring the SDR was sick or something. I don't know. So we grabbed whatever I had lying on a shelf and set it up. And I installed the software stack standing in a snowbank while Jeff was futzing with antennas outside. So, and the antenna on this thing is a piece of twin lead that was literally laying on the floor in a trash heap. And it works great. You can hear Thornton from West Creek. You can hear a ton of APRS. You can hear half a dozen different DMR systems. And how do we know if all the RMHAM gear actually works or not? Well, obviously I have a crazy noise floor at home. I've got some neighbors that are agriculturalists, let's say. But here I can log into this, and especially when there isn't a ton of network loss over the cell network, it works better. And I can hear something at a really quiet site. And this software lets that happen just with a web browser. Obviously, you need network access, and we really do want to. Jeff and I are trying to get this on the public internet so others can use it. But even just knowing that the PA is sick is really useful, right? But you know, I have really no HF capability at home because of the noise floor. So I can come out here and, okay, an RTL SDR, a hack RF is not an ideal HF rig, but you can hear a ton. So I guess it's worth noting, if you want to set one of these up fully, you do need to set up bands for kind of each thing you want to listen to. So you end up with a lot of configurations. This is actually a Pi 3. It has an RTL SDR connected to it and a hack RF. The hack RF has the real antenna outside on the tower. The RTL SDR has like 3 inches of wire stuffed in the bottom of a telecom rack. But that's interesting too, right? Because you can listen to the leakage off the coax and debug transmitters that way. But you do need to go through, and it's kind of a pain to configure every last ham band or other thing you might want to listen to. What else is on here? Not sure what M17 is. DRM, that's HD radio broadcast. Whisper, the different PSKs, if you've got a pager system. I don't know if those still exist in Colorado or not. Listen to that. Sure. Regular AX25 packet. There's a ton of that along the Front Range. So that's interesting to listen to sometimes. I know the Aries folks are pushing WinLink, so there you go. If you want to look at the spectral layout of a signal, we can zoom in and out. If you're just listening, you have a squelch, and you can see this green bar goes not green when it's squelched. So make things easier to listen to. I don't know. What else can I show people?
Just had a question. So if you've got a configuration set up on one of these and you've got several that are going to be the same, are there some configuration files that you can pull out so you don't have to redo all of this work on another, installation at another site?
Absolutely. There's a text file. Where it lands is configurable. In the Raspberry Pi image, it ends up in like var lib openwebrx, something like that. But it's just JSON. If you wanted to, you could configure this by hand that way too. Overload. Oh, right, yes. And again, these don't have any front end filtering to speak of. So if you wanted to make this better for a particular application, put some sort of bandpass in front of it. Yes, there you go. And if you look on the web, there's a company called MiniKits that sells a few generic solid state bandpass filters that you can, they're really simple. It's a couple caps and a couple inductors soldered onto a board. So it doesn't take a lot of money to do this, but that will help a lot. On the other hand, if you don't know what you want to listen to and you put a 6-meter bandpass filter in front of it, you're more or less limited to 6 meters. So we put up with the DMR desensing us and we get to see whatever. Of course, these are cheap. So if you wanted to put 20 of them on a serious computer with different filters, nothing's stopping you from doing that.